Welcome to the Dynamic Learning Hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily life.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works. And it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exams to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates.
Good evening, all. I hope my voice is audible to everyone. Students, I request please inform your friends to join the session, as I can see the participants are very less. So I request please inform your friends to join the session as soon as possible. Shahid sir, good evening.
Yes, good evening, ma'am.
Yeah, you can start the session, sir.
Okay, ma'am. Thank you. So, good evening, participants. Good evening, students. So, let's start today. Today's agenda that we are going to work on dataset. So, let me first share my screen and show that how dataset looks. And we are going to work on the dataset. And before going to do any machine learning modeling and all these things, we want to go for the data pre-processing and data cleaning and all these things. So I hope my screen is visible. And today we are going to work on the data pre-processing, the data analysis, exploratory data analysis, and feature engineering. Okay, so we look little bit theory, and we will implement on real life data set what all these things are. So let me show you the data, and from where you can download the data. I will do all the things. So this is a CSV file, and in that CSV file we have different columns. Okay, so in machine learning, when we are going to deal with these type of the data, so we are going to call these columns. This is just serial number. This is unnamed column is there. So what we are going to say, this is we can remove this column. Generally, we don't need that this type of the unnamed columns. Okay, this is just serial number. This is giving, and this is ozone. So you can take this ozone as a feature. Okay, this solar.r as a feature, and whatever the data we have. Okay, so in that data we have the feature, and generally we call this as the input features, and one is the label. Okay, so yesterday we have seen here in our data set that cars and the bikes and other things were there, and in that we have labels. Okay, cars and bike, car, bike, and bus. These type of the features were called as the labels. Okay, so whatever the data we have, let's say this first data, this whole thing. So let me go with detail that how we can go with our data. Okay, so this whole thing first, sorry, okay. First, you are taking first observation or the first example. Okay, so this whole thing will be your first example, and in that in that thing, whatever this, it may be depending on your data set that which type of the data you have. You may have labels like this. Okay, that is yesterday we have discussed. Like you may have label like categorical data, categorical. Okay, so here we have S, C, and PS. Okay, so this is basically related to the this data related to the weather and ozone, wind, temperature, something. All these things related to weather and yeah. So what is the wind speed? What is the temperature? What was the month and day and year? Okay, temperature here in Celsius and here in Celsius. It's also in Celsius. So we will take this type of the data that we are going to clean and we are going to deal all different things. Okay, so you'll find here some values are missing. Some values are missing here. Okay, and here in this temp C you can find here all data points, all these data points. These data points are in basically numeric values. Okay, but here you will see that this data is given as C. Okay, so we have to deal all these things, and if I go to these things. Okay, so depending on your data, one feature you will have as label. Okay, so this whole thing weather will be treated as label here in my data that we are going to take today, and all these data points, all these from here to here, all these features will be treated as input feature, input features. Okay, so we are going to deal with the label and the input feature. So on the basis of the input feature values, let's say these values up to here, we want to find out whether this data, this particular data, this will include also this one, belongs to which category. These categories, these three categories we have. Okay, so we'll try to find out. This will fall into the classification, and we will go in, when we will go to supervised learning and classification. We will see. But first, we are trying to find out input features. Okay, so up to here, let me clean all these things. Okay, so in this will be weather column. Okay, and this will be your label. Okay, so label in your data set, you will have one column that will be your label, means if it is supervised type data set you have. Okay, so label will give you the either it will be categorical type like this we have, either SC and PS. We will look into that what these things, cloudy or the sunny or the partly sunny. Okay, so categorical type, either we have discrete values like 1 2 3 4 5. Okay, either we will have the continuous data. Okay, so depending on this label values, we are going to perform different type of the task, whether classification task or the regression task. Okay, so all these up to here, and except the label, we are going to treat as input features. Okay, input features. So here, ozone, solar, wind, temperature, month, day, year, and temperature. These will be called as your input feature, and this weather will be called as the label. Okay. So this data from here to here, all these data belongs to which category? Okay. So this type of the data you may have. In this data, we have different things that we have to deal. Okay, we have to deal with null values, we have to deal with this type of the data that it's not following, it's all data containing the temperature, in Celsius containing integer values or the numeric values, and some data are like text data. Okay, so different types of the cleaning and pre-processing you will see. So this is our data that we are going to look into. So we need this data from where you are going to download something, from where you can download. So I have created a repository here, okay, in GitHub, and you can directly go to this. I will share the link here. And dataset, and we are whatever the okay, dataset clean data. You can download this data, and I have also uploaded the Jupyter notebook. Okay, so you can download these two. So I will share this. Okay, this whole thing in the chat. Okay, I will share this thing. I'm sharing. You can download. Go day 10. Today, day 10 is there. And in this day, we are going to perform the data preprocessing and feature engineering and exploratory data analysis. So we will do a lot of things. Okay. But before that, as yesterday I said that machine learning, before going to machine learning, you need your data. Okay. So first we will deal with data. We are going to clean the data, and we are going to do a lot of things. Okay. So you go and you download your data here, this clean data.csv file. And later on, we will look some theory that what data cleaning is and what different types of the methods that you are going to see into exploratory data analysis and feature engineering. Okay, so these three things we will look into, and we will do Python programming using your Jupyter notebook or Colab. Okay, so better I will do in the Colab. Okay, you can do in your Jupyter notebook, and this you can download, and how you are going to work with the Colab, I will show all these things. Okay, so first go and download these two files, and side by side when we'll implement the programming. Okay, so side by side, if you can run the programs, you can run the things, so it will be very good. Okay, so let's move to the a little bit theory. Okay, because theory is important. Whatever you are going to do, why you want to do this thing, you have to understand. Okay, anything you want to do, anything you are doing in machine, in any project. Okay, so first thing you have to understand what you are going to do. So let me show here that what different things that we are going to do today. Okay, so one thing that we want to do, that try to understand this one, like we have algorithms. Okay, any machine learning task you are going to perform, so ML project or machine learning task. Okay, so you need data. So first thing is that data. Without data, you are not going to do any type of the machine learning project. Okay, so all the things that you want, first you need your clean data, your perfect data, as you are going to input the data. Okay, if your data is good, if your data is clean, if your data is standardized, okay, means everything is good. So like way your algorithm will be trained. Okay, so whatever the algorithm for the classification, there are different types of the algorithms. Okay, we will look into all these things. For the regression, you have different types of the different types of algorithm. Okay, for clustering, you have different types. Okay, there are lot of the algorithms, but those algorithms are not of any use if you are not going to train on the data. Okay, so data set will be for your specific task. Okay, so if you are going for the classification, you have data, something like that. Okay, so which type of the data you have, what the project you are going to do, what is the problem statement. Okay, so on the basis of you are going to perform. Okay, and when you are going to do the training, okay, so this algorithm will learn patterns, will learn some rules, will learn some different types of things it can learn, and on the basis of those things you will get model. Okay, so how we will see that how to select your algorithm, how to train on the data, okay, and how you will get the model and how you are going to implement the model in your program. Okay, so first thing is to understand the data. Okay, so we are going to deal today. We are going to deal on the data, that how to clean the data. What is the cleaning? What is the cleaning of data? Okay, what different types of EDA exploratory data analysis you can perform. Okay, what are the features you are going to do? Okay, and what different types of the feature engineering. Okay, so there are a lot of things that we have to do. So quickly, let's go to the little bit theory and try to understand what different things are there and we are going to implement. Okay. Okay, it's displaying something that we have in that is not running. Okay, something I have written that is not running. Okay, no issue. You download that, and after downloading, okay, when you will open, it will work. No issue. Okay, everything is good there. Okay, so in that thing, something is not. Some shells are not running. Oh, that's why it's showing invalid. Okay. So some cells need some external data and external libraries that were not actually running. Okay. So that's why it will not open in GitHub. Okay. But when you will download and when you will open on your local machine, okay, either in Google Cooler, it will be okay. Okay. These things. I will show how to do all these things. Don't worry. You download first these two files, like IPYNB file, that is eda.ipynb, and the data. Okay, so no worry. In GitHub, it will not show exactly. There are some errors in the shell, and I have those things. Okay, so that's why it will not show in the GitHub, and we'll download. Okay, it will work. No issue. I will show. Let's go first these things, how it will work. Okay. So today that we are going to deal with data cleaning. Okay, what does data cleaning means? Missing data. Okay, and machine values we are going to work on. Data analysis and visualizations we will work, and transformations. And if time will permit, I will show you some EDA libraries that directly you can work. Okay, so let's move quickly. Basically, EDA is nothing but EDA you can perform anytime. Okay, you downloaded, you collected your data, and you are going to perform EDA. It's just you are going to understand. EDA is what? Exploratory data analysis. Okay, so in the EDA, you are going to perform. Just you are going to understand your data set. Okay, whatever all the things we will do the Python programming. Okay, and you will see exactly how on the data. Okay, whatever the data set that I have given for the ozone and all these things, you will see different things, all the things, how to clean and describe all these things. So just to understand, describe data sets, how many columns, how many rows, whether data has missing values, what is the data types, and all these things you will get. Okay, data cleaning means it will be like if you have missing values, if you have invalid data types, so what you are going to do, whether you are going to delete such type of the data, or you are going to or you are going to replace some other values. You will see the outliers also. Okay, if you have outliers, so what you are going to do? Okay, whether you are going to delete those rows and columns, or you are going to fill with some other values. Okay, so for the visualization, you can work on the bar chart, histogram, different types of the box plots are there, different types of the plots are there, and using those plots, you are going to understand that which type of the data we have. Okay, what is the data distributions and different things. Okay, so in the EDA, you are going to just understand, okay, the data. Okay, and yeah, correlation is there. We are going to understand the correlation. So in the data set, if I show you, okay, this is the data. So correlation means we are going to understand whether wind is correlated with weather or not. Means if wind is increasing, then temperature. If we are going to find out there is a relationship between wind and temperature or not. Okay. So if wind is increasing, whether there is any relationship with temperature or not. If there is any relationship with ozone value with the wind, is there any relationship whether like ozone is increasing, so temperature is increasing or not, whether solar radiation is increasing, so it has any relationship with the ozone or not. Okay, these type of the relationship you can understand with the correlation. Okay, so we have different way to understand, so we will look into that. And data cleaning or the cleansing, just to remove the unwanted data if it is inaccurate or it is not available. Okay, so the different types of the thing, incorrect or they are inaccurate or the incomplete data. Okay, so here in dataset we have missing values. We have a data here, you can see here in temperature in Celsius, we have a data something inaccurate. Like all the data here are the numeric value, but one data we have here that you can find. One data is C, that is our text data. Here in the month, we all have the numeric value, and one value we have here, the May, that is text data. Okay, so this type of the data you have to deal. Okay, if data is inaccurate, incorrect, so what you are going to do? Okay, so there are different types of the data quality check: validity, accuracy, and completeness, consistency. So we are not going to deal all these things. Okay, we will check and we will understand. Okay, so what are the outliers? So in your data set, in your data, this, let's say that this is your data. Okay, let's say here wind is there. Okay, so you have all the data in the numeric as a numeric value you can find here. Okay, so you may have some values that are very uh, like extreme type of data. All the data, if you can find 10 point, 15 point, these things 15, 10, 7, 8, something like that. Okay, 11, 14, 14, 14, something like that. And if I have one wind value, let's say 100. Okay, let's say wind value is 100, so all data points are around 11, 12, 13, 20, let's say in the range of the 0 and 20. Okay, and one data is one or two data points are like 100 or 80 or something like that. So these type of data will be treated as outliers. Okay, so there are different ways to find out the outliers. So one is using box plot. Okay, so histogram or the box plot, but I will recommend go for the box plot. We will create all the things like histogram also and box plot. You will see that how it works. Okay, so this will box plot is very important when you are going to deal with the outliers. Okay, so this whole thing you can find here, this upper limit and lower limit. If any, there is interquartile range concept to deal with the outliers. Okay, and when you are going to deal with the box plot. Okay, but for now, to understand that how you can check that whether my data set has any outlier for a particular feature or not. So here ozone is a feature. You can see here all the ozone is one feature, input feature. Solar.r is another feature. Wind is another feature. Okay, so there are different features, and temp is feature, weather is feature. Okay, so one feature you can check, you can plot box plot, and you can find whether there are any there are some outliers or not. Okay, so if you are getting this type of the box plot, this will be the maximum value and this will be the minimum value that will be in our range. Okay, so these two data points are out of the range. Okay, so we are going to treat them as outliers. Okay, so you can check whether any feature contains any outlier or not. Okay, so now if you find that this data ozone feature has two data points that you are going to deal as an outlier. Okay, so it's up to you that how you are going to deal with these outliers, whether you are going to delete those outliers or you are going to replace these outliers with some values. Okay, so sometime we are going to replace these values with the maximum value, maximum limit, or we are going to replace with the median value. This is our median value basically. Okay, and this box will give you the 50% of the data that lies between these boxes. Okay, so we'll see all these things when we'll do the programming. Okay. Okay, so to find out the outliers, another way to find out, like you have in Pandas, we will see that dot describe method. Okay, if in describe method using this thing, maximum is this in 168 and 75%, 25%, 50%. This will give you the statistic. Okay, descriptive statistics about your data, this ozone. Okay, so how many data points you have in the ozone group. Okay, ozone feature 116. What is the mean is 42. What is standard deviation, minimum, all these things. Okay, so 50% of the data, this 50% is treated as your median. Okay, so we are going to deal that median is our median in our data, median is 31.5. Okay, and maximum value says 168. Okay, so you can find out that maximum value is very far away from the median. Okay, so one way to find out, like check just guessing using these descriptive data, you can't go directly that say that this is this value or something, some values are the outliers, but one guess you can find that this will be outlier. Okay, so this is another way to find the descriptive statistics, that if any data is very far away, very large, very far away from our central data, that is mean, basically we are talking about this 50% data. If your maximum data or minimum data, okay, very far away from your 50% data, so you can find that there are some outliers. Okay, so one way to deal outliers, to check outliers like this, you can do the box or the bar plot. Okay, bar plot like this. So all the data are ranging in this between this. You can find here this two. What is this two? So month 9. So these are the month values that we have in month column. Okay, so you can check here in the month column. Let's say 5 and May is there, 6, 7, 5, 6, 7, 8, 9 are there. Okay, so in some data, this month 2, the count is only like 1 or 2, something like that. Okay, so this may be treated as outlier. Okay, because all the data related to May, June, July, August, and September. Okay, so this may be this data for the February. Okay, may be an outlier. Okay, so you can check for this categorical data also. So for the continuous data, you can go for the histograms. Okay, so for the, if you have continuous data, like here, you can check here, we have continuous data, means we have data in the, okay, sorry, this wind, you can find we have continuous data. Okay, solar, somehow you can say, if it is like, if you maybe the value may be in points, ozone may be value in the points. Okay, and if your data is something like that, categorical or discrete type. Okay, so here month, you can say only 5, 6, 7, 8 things are there. Okay, or okay, so if your data is categorical or your data is discrete, so you can perform the bar plot. Okay, continuous data, you can go for the this histograms. Okay, so you can check these things. So when you find that whether there is outlier or not, so what can you do? Okay, so there are some ways that you can handle the outliers. Okay, either you are going to delete the outlier, or you are going to replace those outliers with some other values we already have discussed. Okay, so in the data cleaning, we are going to do these things like duplicate. We are going to check whether in our data there are duplicate values or not, duplicate rows or not. where we are going to rename columns, column value you want to rename or not. Okay, there are different types of the task that you can form. Okay, so let's say that you are going to rename this solar.r, okay, with different name. You are going to see. If you are going to check that temperature C and temp data, both are looking same, okay. So, but here some missing value is there in temperature C or with categorical data, and here you're going to see that it is numeric values, okay. So all the numeric values, but here you have some categorical type of the data. Here all the numeric values. So there are two different column names, but having same type identical data. So what if this type of these things? So what you are going to do? Whether you are going to drop unnecessary columns, okay. So you can drop if your columns are something like that, the duplicate type, okay, or the some identical values you have, okay. So what can you do? You can delete or the drop the columns. Okay, yeah. Convert the data type. We'll see all these things: removing string in the column, all these things, outlier, handling outliers. Okay. So let's move to our collab, and we will do something related to cleaning, and then we come back to here. Okay, so missing values and other things. So all these things we are going to see. So let's move to the our. So first, what you have to do? First, here your data. Again, I am sharing the link. Okay, if anyone joined late, okay, so he or she can go here. Okay, go to this. Uh, okay, this repository, and what you have to do, you have to download this data and this EDA here. If you go here, so it's not opening here, okay, in the GitHub, okay, but it will work when you are going to download. Okay, so first what you have to do, just go and download these two files, go into this day10, okay, and download these were data underscore clean CSV and EDA, okay. And now we are going to work on our data set, okay. So side by side we will learn some concept, and we are going to implement also. So how you can go, just go and either you can open your Jupyter notebook, okay. Yesterday we have implemented, so you can open command prompt or any terminal, okay, and go to that. You can go to the your folder, okay, where you have the data. I think maybe, okay, so this is my folder where I have all the things, okay. And inside, again, you can go to your data, and that we are going to deal with feature engine, okay. So if you are Jupyter notebook, okay, so you can open your Jupyter notebook, and here in this folder I have my see, this is my folder where I have this CSV file and this EDA, okay, IPY with Jupyter notebook file. So in that, when you open this one, you will get these things, okay. So clean data you have, that is your CSV file, and this sorry, this is PPT that I'm using, okay. So you need not to do these things, and this you will get your EDA, okay. You can open this one directly like this. It will work, okay. There it's not working in the GitHub, okay, because we have some cells that are not running, no issue. So you can go and use this one, okay. Directly you can go if you have installed all the libraries like NumPy, Pandas, okay, and Seaborn, Matplotlib, all the libraries locally if you have installed. If you're working in the collab with respect, should be video set. Yeah, I'm showing. I will show. I will work in collab. Okay. But if anyone wants to work locally, okay, so that's why I showed that how you can work. Okay, I will show you how to work in Colab. Okay, so these data, this file you will get. Okay, all the things whatever it is needed. Okay, so if you have installed NumPy, Pandas, Matplotlib, all the things locally you can do. Okay, either what you can do, we are going to work we are going to open Colab. So you just go and open Colab. Okay, so that's why I'm showing all these things. Okay, if anyone wants to work locally with Jupyter Notebook, he or she can do like this. Okay, and if you want to work on the Colab, so just go and search Google Colab. Okay, Google Colab, you can go here, this one, colab.c. You find here colab.research.google.com. Okay, so if you are working first time, so you'll get only this one, welcome file. Okay, I have done all these things in the previous stage, so that's why it shows a lot of things. Okay, so what you will do, whatever you have downloaded these files, okay, you have downloaded these two files. Okay, so where you have downloaded, just go for the upload. Okay, and just go browse. Okay, so wherever you have, just go into your this. Okay, you will find this one. Okay, idea. So I hope this is somehow, if anyone working first time in the Google Colab, how to upload your local Jupyter files. Okay, local Jupyter notebook file in the Colab. Okay, so you can go like this. Okay, now what you have to do, if anyone has any doubt up to this, like I have shared the Jupyter, I have shared this one. Okay, GitHub, this repository. Okay, I have created today this repository, and within this repository I will put all the file day wise. Okay, so yesterday's there were nothing like programming and these things. We have just introduction about machine learning and how to what are different types of the machine learning approaches, supervised, unsupervised, reinforcement learning. Okay, so those were only just the theoretical type, so I haven't uploaded the files here. Okay, but in this I will create folders, and day wise I will upload the files. Okay, so this is the 10th day for whole program. Okay, like projects excellence, student development program on this. Okay, so I'm dealing with machine learning part only, so I have created this one for the machine learning part. Okay, so today's you go here and download these files. Okay, and when you have downloaded and you have uploaded. Okay, so what you need basically, let me make more. Yeah, now I hope that it is visible and it will be good to understand. Okay, so what you need these two. Okay, these libraries are the packages. Okay, NumPy and Pandas, Matplotlib, Cborn. Okay, so Pandas is very important, that we are going to deal Pandas. Okay, we are going to work, sorry, we are going to do all the things, EDA, data pre-processing and other things using this Pandas. For the visualization, we are going to use Matplotlib and Cborn. Okay, so for the visualization, you need these two libraries. Okay, you can work with Pandas also. Every visualization you can do with Pandas. Okay, no issue. You can, but this is Matplotlib, the basic that Pandas uses behind the scene Matplotlib. Okay, so we are going to import all these things. So you can run this by clicking this or shift enter or control enter. Okay, so what you will see here, it will connect first. It will connect with the RAM or RAM. What will be the RAM? Okay, you will find here that is 1.28 RAM is available. Okay, disk size available. Okay, so this Colab is provided by Google and everything is free. You can directly go. Okay. So virtually you have 12.6 GB RAM available. Okay. And 107 GB disk. Okay. So this is more than enough that you can do any type of the data science or the machine learning project here. Okay. So you run this one, okay, using Control Shift or just you can click on this, okay. So one thing that you need to upload your data set. You need to upload your data set in this file, okay. So this is the way that you can put here your data set here. So in this file you can put anywhere, but most of the time we are going to put inside the sample data, okay. Most of the time we are going to put in the sample data, and outside sample data also you can put no issue. So how can you upload? Just double click here and you will get not double click, right click, okay. So right click, you will get open, upload, new file folder, different types of the options you will get, okay. So for upload you can go and you are going to upload, okay. So whatever the data you want to upload here, you can upload data, files, and different things you can upload, okay. So you can upload this CSV file clean and data underscore clean, okay. Just open this one and it will show you that it will delete where your runtime is terminated, okay. So no issue, just we are going to upload and we are going to work on this. And when runtime is terminated means when you terminated your this runtime, okay, so it will be deleted, okay. Your uploaded data will be deleted. Here you have some default data: California housing price, California housing test train data, and east and other things. And whatever we have uploaded here, you will get here like data underscore clean, okay. So what you can do, right click again and you can find the path, copy the path, okay. So now you can put here. So the second step that you have imported, first you imported all the necessary libraries, NumPy, Pandas, and these things. So we are going to use this pandas.read CSV, okay. This is to read CSV file, okay. So we have this data, you can find here this data as CSV file, okay. So you can put here whatever you have, copy it from here, okay. So for the path, where this path is, you can copy and paste here and you can run this one, okay. So one thing is that we have uploaded our data and we have read our data. Close this one, you can find this, okay. So we read our data as pandas data frame, okay. So you can check, you can clean, you can go here like this, you can click and you can do for the next cell, okay. Either you can go for your code and text and other different things are there. So you are going for the code, you will get some extra this a shell, okay. So what you can do, just you can check that what is the type of this data frame, okay. So you can find this is basically pandas.code.frame data frame, okay. So whatever the data inside this clean data underscore clean.csv, this CSV file is, now we have uploaded as a pandas data frame, okay. So now we are going to work on this pandas data frame and we are going to see different things, okay. So first is to understand the data. So what you can do, data frame.head will give you by default 5 data, 5 rows it will give you, okay. So 5 rows it will give you. You are going to understand what different types of the data you have, what different types of the these things, okay. These features, ozone is another feature, solar.r is another feature, and all these things. So these are the feature names and these are the data points that you have. First data point will contain these values, okay. So you can check and you can, if you want, not only 5, you want to find 10 different, okay, different values, different, so you can go, okay. So it will give you from the starting first to 10, okay. So from 0 to 9 it gives the first 10 data points, okay. For the shape, you can understand data frame dot shape, it will give you how many data points we have. So it has 158 rows and 10 columns. Okay, so you'll get 1, 2, 3, 4, 5 to 10. 10 columns it has and 158 rows it has. Okay. You can go with data frame.columns. You will get all the names of the columns. You'll get all the names of the columns. So how to get 10 rows? Okay, so 10 rows, just head is there, na? So you have seen, if you have only head, okay, if you are going to put only head, data frame dot head. Head is a function. Okay, head is function that it will show you. The head function will show you the first 5 rows. Okay, first 5 rows means from 0 to 10. You can find here, you can go here, I will check first, second, third, fourth. These will be the starting 1, 2, 3, 4. Up to this it will show you. Okay, so up to from 1 to 5 it shows. This is from 0 to 4. This is default indexing. Okay, in Pandas. Okay, so it will show you the default indexing, and this unnamed column we have in our data set. Okay, this is unnamed column 1, 2, 3, 4, 5. Like index or the serial number we have 1, 2, 3, 4, 5. So this shows first 5. Okay, and if you want to find 10 or 20 or something like that, okay, so you pass just the number how many rows you want. Okay, so if you want 10 rows, you can just give here 10. You want 15 rows, you can just give 15 rows. Okay, so it will give you from 0 to 40. That will be in total 15 rows. Okay, I hope this is fine. So you can find the columns. Okay, what are the columns? Data frame dot columns for different data. Your data set, your CSV file has different columns. Okay, so this is data frame, Pandas data frame, and how many columns are there. So all the column names. First was unnamed. Okay, ozone, then solar dot, or then wind, temp CSV, month, day, year, and all these. Okay, so all these things you can find. And one important thing I want to show, that you can find here weather is there. Okay, so SCNPS different. Only we have SCPS type of the data here. Okay, so these are the categories. Okay, so whole all this data from here to here, this belongs to C weather. Okay, C category. This belongs from here to here. This data belongs to PS, partly cloudy or partly sunny type. This is sunny, this is cloudy, it is partly sunny. Okay, so you can see for any feature, what different counts are. Okay, value counts means how many times this S appear in this feature. Okay, how many times this C appears in this feature, how many times this PS appears in this feature. Okay, so you can run this and you can find in the weather feature how many times PSC, these three are there, and these S appears 59 times, C appears 49 times, and PS appears 47 times. Okay, so these are the basic understanding. Because you know why we are doing all these things, because we have our data here. I have taken only 158 or 160 data points, but if you are going to work on the real live data, you will have millions of the records. Okay, millions of the rows. Okay, so you're not going to read all the data points or the rows one by one. So all these things you can check, and you can understand what different types of the data you have, whether you have duplicate values, whether you have missing values, or different type of things. Okay, so for the data.info, so this is very important. This function will give you a little more information. It will give you all the features here. See, unnamed, that was the first feature. That this is only what, this is only the serial number 1, 2, 3. Ozone values, solar dot, this will give you the values, month and day, and all these things. Okay, and it says that how many not non-null means 158 non-null, 120 non-null. So rest of the values, like total we have 158 and not null is 120. Okay, so rest 38 or something like that values will be null values. So you can get something here, and you can find here all the data types for different types of the values a respective feature has. Okay, so this wind has float 68. So this wind contains float values, and this month contains objects. So in Pandas data frame, when we are dealing with the text data or when we are dealing with a string, okay, so that will show you an object data type. Okay, so if it is integer, it will show you integer. If it is text type data, it will show you object. Okay, and if it is in decimal point, so it will give you float. Okay, so you can find data frame dot d types, and this will give you this one, data frame and data types that we have already seen. Okay, so if you want to check only data types, you can check what different features, what different columns has the data types. Okay, so these things you will get. Another very important feature that we have gone through this one, that what are the descriptive values here, outliers to check. Okay, so you can go for the descriptive value also for any feature if you are going for the data frame dot describe only. Okay, so what it will take numeric features only, because you see here in our data frame, there are different types of the features: ozone, solar, wind, and all these have numeric values. So see here, these float: ozone has solar, wind, and day, year, and temperature. These are the numeric values, but weather and month and temperature, see. Okay, so these are categorical type. Okay, so they somehow has some text data somewhere or the string values, so they are the categorical data, and here this shows that object. Okay, in the pandas data frame you will find as object data type for the string values for any feature that contains string or the text data. Okay, so the describe will show you for only the numeric values. Okay, so all these things, all these information, so you can understand the data that how many counts of ozone is. Okay, so ozone has not null values 120, it has 151. Okay, so the rest of the values may be null value. Okay, so 158 total, we have 158, and it is only 120, so rest of other are null values, mean, standard deviation, and different things. Okay, you will get. Other feature is that you are going to check that whether is there any null value or not for the respective features. Okay, for the respective feature, so it will give you features like here we have ozone and this month, day, year. Okay, temperature, weather. Okay, so by going your data set here like this, you are not going to check that how many null values a particular, this is not available, this is not available. This is null values. Basically null value means here that actual data is not provided, this is empty. Okay, so this is empty, this data is not provided for this particular feature. So what you are going to do, so this is null function, you can use it is null function wherever, let's say this, if you are running this is null, so wherever true is there, this means this function is returning true if the value is not provided. Okay, value is empty, there is no value provided. Okay, so we are going to just sum all the values where null is there. Okay, so in ozone there are 38, in ozone there are 38 places where values are not provided. So all these things NaNA you will find, all these NaNA 38 values are there which are nulls. In solar.r you can find here, you can go solar.r NaNA. Okay, so these are the 7 places where these are not available. Okay, and in weather column, in weather feature, somewhere NA will be there. Okay, there no data is provided, so you'll find here that there's no data is provided, no data is provided. So you have 3 cells where data is not provided, so there are 3 places, there are 3 null values. Okay, so this way you can check different things, you can find out what different things are there and how many unique values. Okay, so one thing that I want to show you, for any feature if you want to write. Okay, so how can you write, basically how can you check and for any feature, so data frame, and if you want to find, let's say, this feature, This one is what? Wind. Okay. So what you can do inside that, just write exactly what the name is. Okay. So you will run wind is there. Okay. So column is wind, you can find here, or just you can go for the data frame dot head. Okay. So if you want to go data frame dot head, you can go like this, and it will show you 10 the first five rows. Either you can go with the columns that we already have seen columns, and it will give you the column names. Okay, so you take any column name, let's say that feature, that this temp c, so you can put here temp c, and it will give all the values. Okay, and in that, let's say month is there, month you want to check, and in that you want to check that how many unique values are there. Okay, what does unique values means? That how many different types of the values are coming. So it contains only 5, 6, 7, 8, 9, and may is there. Okay, so all data, this 5, 6, 7 are written in this number type, but how it is stored? They are numbers but stored as a string. Okay, because one data we have that is in string. Okay, so this is a string, and it so this all the data is treated as a object. Okay, so you find here that what is the data type of the month is, that is object. Okay, so because of this only one data, only this may, it treats all the data that are numeric as a object or as a string. Okay, so we have to deal this type of the data also. Okay, so first thing that we have to deal with is what? Let me show you this one that we were dealing, like yeah, so we are going to deal with duplicate rows. Okay, so if there is any duplicate, okay, so you can count. So let me show you. Okay, like this, it will there are no duplicate values. Okay, so in this basically, so we are not going to do anything. You can find what does duplicate means, like exactly all the values like 141.0, and these things appears somewhere else, like here at the 154th rows, all the values are same as with any other. Okay, so if two rows are same, so those will be treated as duplicate values. Okay, so in our data we don't have any duplicate values, so that's why it's not showing. But if you have duplicate values, so what you can use? Drop underscore duplicates. So what it will do? It will drop the duplicate rows. It will take first row, first unique row, and if any other row is okay duplicate with the previous one, so the second duplicate second row it will delete. Okay, so this is exactly 158, so we are not going to do anything. But if you have duplicate, it will delete. Okay, if you want to do different things, if you want to rename columns, so what you can do? Just a rename function is there. Okay, so this is basically what this is data frame that is cleaned after deleting duplicate, if you have duplicate basically. So those who are the late. Okay, so I can, if they can find this one, so that is very good. Either I'm again sharing the GitHub repository. You can go and you download these two files. Okay, you can go to the GitHub repository and you download the files, and you can practice along with me, that you can practice. Okay, so any doubt, you can put your doubt in the chat, and I can check the doubt, and I can take the whatever the doubt is. Okay, so if you are not able to download, if you are not able to do any programming or anything you want to understand. Okay, so whatever you can do, rename function, and you can use, this is our old name in my data set. Okay, data frame, this is the old one, and this is going to be replaced by this one, solar. Okay, so axis one is going to do that column wise. Okay, for the columns, So whatever we're going to use for the earlier, it was solar.r, this one, solar.r. Now I'm going to replace this column name by this solar. Okay, so what I will do, I will run and I will find the second cleaned data that here you will find that it is solar. Okay, now this solar.r is replaced with solar. Any data if you want, like temperatures you want to replace by temp c and other things we will see. Okay, so I hope up to this you are getting the points. Okay, and anything, if you have any doubt, you can just put in the chat. I will look into. Okay. Second is, if you go and check with temperature C and temp. Okay. See here in this rename column, drop unnecessary columns, and all these things we are doing one by one. Okay. So if you go and check temperature C and temp. Okay. So this temperature C contains. Okay, someone has, if axis is for the column, then for the rows, what we should use. For the rows, it is 0, and for the columns, it is 1. Okay, so if you are going to work on the row basis, so you can put here axis as 0, and for the columns, you are going to put as 1. Okay. So here, if you want, you can check here temp C and temp only temp. Okay. So it is basically temperature in C, but all the data, if you go here in your data set, an Excel file, this is not basically Excel, but it's CSV file. Okay. So what temperature C, one data here you are getting C. Okay. And let me show you with the working also. Before that, you are going to work with this. Okay, so one put here. Okay, so data frame, and in this basically put this temperature C as either in the single quotation or double quotation, no issue, and you will find dot unique. Okay. Okay, so it will give you all the unique values. Okay, so you can find here like 67, this, all the unique values. Okay, like in this column or in this feature, 67 appears. Okay, so here you can find C is there. Okay, so C, because of this C as a text data or the categorical data, text data basically, all the data is treats as an object. Okay, and I'm saying again that this object, okay, in data frame or the pandas data frame, any text data or the string data will be treated as an object. Okay, so because of this C, this is going to treated, all the data is going to be treated as like a string. Okay, so that is not good. And you can find here this temp C contains a string. Now here temp is containing the what? It contains numeric value. Okay, and both are same, values are same. It contains 67 as a string and it contains temperature as a numeric value. Okay, so here 72 as a string, here 72 as a numeric. Okay, but we don't need two columns, those are identical. So what we will do, we have temperature, so temperature should be numeric. Okay, so we are going to take this one and we are going to delete, we are going to drop temp C column that contains temperature values in string. Okay, so we don't need temperature values in a string, we need temperature values and numeric value. So we are going to take this temp and we are going to delete temp C. Okay, so what we can do, okay, here we are. Okay, so you can do dot drop. Okay, so if you want to delete any column, any that particular column with along with all data. Okay, you want to delete one feature, that is temp C, along with all the data we are going to use whatever data frame name is data, a clean data, because we have cleaned here using, we have renamed and other things. So we have cleaned data frame data underscore clean to now. Okay, and you can perform on your own data, that is there is no issue. Okay, on your own original one. Okay, so temp C is going to be dropped. Okay, and the axis is equal to 1, that is column wise. Okay, whole column will be deleted. So you will run this and just print this one. Okay, now after deleting temp C column, we are going to take this whole data frame as a data underscore cleaned 3. Okay, so here you will see that temp C is deleted. Okay, in our data. Okay, so now you will get only temp here and temp C is deleted. So we have dropped one column that was unnecessary. Okay, because why it was unnecessary? Because the same identical data we have that was in numeric, and that particular data, this contains temp C contains the same data, these same data points, but as a numeric because of this C value. Okay, so now we have deleted this temp C, and now we have only one column with all the temperatures. Okay, so now we have done what the things that we have done. We have renamed the solar. Okay, earlier it was solar.r to solar, and we have deleted all the this temp C column. Okay, so these two things we have done. What other things that you can do? You can check here, different things are there that we are going to perform. Okay, so data type conversion you can do. Okay, what the thing is data type conversion. If you go and check, let's say one thing dot d types. Okay, so what it will give? It will give the ozone that is not D type, but basically we are going to deal with our this. Now we have cleaned and we have some different things. Okay, so you take cleaned data, and this thing you can check. Either you can go. Let's go with the data frame. Okay, that original data. So this is don't confuse. This is the data frame, that original data frame that we have uploaded, and cleaned data free. This is basically what that we have done some cleaning. Okay, so after this, what you will get? This see here we have ozone, that is float, numeric value float, and temperature C that we already have deleted. So no issue. Month in object, that is one thing that we have to focus on. Day, year, temperature, that is fine. Okay, so month is what? Month is in object, temperature C, and other things. Okay, so if you go and find month, if you go, okay, we have here, if you go and find month. Okay, let me show you how month contains different things. So what you can do, data frame, and go and check for the month. Okay, so you'll get all the values in the month and dot unique. Okay, so month unique values. Okay, so you'll find 5, 6, 7, 8, 9, and one value is May also. Okay, so May appears because of this May. It is now our what? It is object type. Okay, either it all the values like 5, 6, 7, 8. These are the month values, but in numeric data. But because of this May, all the data 5, 6, 7 are treated as the string. Okay, so we have to deal this. How we are going to deal? We are going to convert these values to the numeric. Okay, so all that we are going to change basically the data type of month feature to the numeric. Okay, so you can take a copy of this. Okay, and what you can do, you can basically do one thing. There is a function in Pandas data frame. Pandas provides a function that to numeric. Okay, so directly you can perform to the to numeric, or you can, what you can do, you can replace all the just let me check here, replace function that rename, or okay, what you can do, you are going to convert numeric value to the that object values to the numeric value, like a string. If a string contains a numeric value, it will convert into the number. Okay, if your string contains here, let's say here like 5 we have. Okay, so this function to numeric will convert to the 5. Okay, if your some value contains like this May. So if you are going to use squares, so what it will do, it will convert into not a number. Okay, so if your string contains numeric values, it will convert into that numeric. Okay, if your string contains some text data, so it will convert into not a number. Okay, so you have to deal, how you are going to deal, you have to look into. Okay, so all the data basically in that month, either 5, 6, 7, 8, 9 are there, but one value is May. So because of that one value, this is creating a problem. So we are going to deal with. Okay, and you can do for month. We already have deleted temperature C, but if you have not deleted temperature C, so you can do also like this. Okay, so one column, one value in temp C column was C only. Okay, and other values like 35 all were in the values 34, 30, 10.5. All these values were the numeric in a string. Okay, they were the numbers in the string, so this value to numeric will convert into 35, this 34 will be converted into 34. Okay, 10 will be converted into 10, because this string contains only numeric value, so this will be fine, this will convert. But if a string contains non-numeric value, so what it will do, it will convert into not a number if you are using coerce. Okay, so it will do something like that. And weather category. Okay, weather. Okay, so weather is basically what object type of the data, and pandas data frame also provide another category and other data type as category. Okay, category. Okay, so you can use category data type. This is very important when you are going to deal with categorical data. Okay, so if you have data, if you have label, you have label in category. So here we have cloudy, sunny, and partially sunny. So we have only three categories or only three classes. Okay, are the categories. So one way category that you can convert into category. If you're not converting into category, that is also fine. But if you are converting into category data type, that's well and good. Okay, so these things you can perform. And okay, you can run and see data is not defined. Okay, sorry. So whatever this, you just go and do this one where data frame dot copy. Okay, so what this will do, data frame dot copy, some message with that. If x is okay, yes, very good. Sir, could you please create a GitHub repository and talk this one? Yes. I have created and already I have shared. Okay, I have shared the link of the repository. Okay, I already have shared the link of the repository. Again, I'm sharing. I think you are just late joiner. Okay, I have shared the repository and I have all these files, dataset and this IPYNB files. Okay, so day wise you'll find here. Okay, day wise I have already created where it is. Yeah, so this is, I've shared the link. You yeah, so say for you also I've shared the link. So this is the repository name, and inside this EDA pre-processing and all these things I have. So this is the dataset.csv file and this is the EDA. Okay, that IPNV file. You can check, you can download and you can upload to the GitHub. Not GitHub, the Colab. Okay, you can work. So I have already done these things. So you go, and if you are new to the Colab, you can go like this. Yeah, you're most welcome. Okay. You can go and you can upload notebook here, and you can browse, and you can upload your EDA, whatever you have downloaded the files. Okay, and you can work. So just do this one, dataframe.copy, and run this one and run this one. Okay. Sorry. So now if you are going to check that data.info, so now it will be showing you what the weather is of category data. Okay, and month is now float data, and anything that we have changed here, temperatures. Okay, temperature C is now float. Okay, earlier what it was temperature C object, month was object, and weather was object. Okay, so now you can change the data type of a particular column, a particular feature basically. Okay, so this is another thing that we are going to do in the data cleaning or in the exploratory data analysis or the data cleaning steps. If your feature contains numeric values, but the data type of that feature is, let's say, categorical or the string or the object, and all the text and string, all these type of the data in Pandas data frame is treated as an object. Okay. So all the data is numeric, but the feature data type is object, so you can convert into the numeric. Okay, so this function you can use that to numeric, and on the basis of the values it will convert into either int or the float. Okay, so all the values here converted into wind is converted into float, and here you can find the temperature C in is converted into float, month is converted into float, and weather is converted into category. Because what? We have used this as category data. We are going to set, just we have set the category. So now what other things? Just you are going to deal with outlier. Okay. You are going to check the outliers. So other things, you can change the data types, you can work on the outliers. Okay, so what is that? What are the outliers? Let's say all the data you have in a particular field or in a particular feature. Okay, so ozone feature is there, and okay, let's go with proper example. It will show you. Okay, so you can create histogram of particular feature. Okay, so what you have to do, don't confuse that this is the data frame name. Okay, you can give your actual data frame that this we have taken. Okay, and within that you can put your ozone. Why I have taken here clean data 3? Because we have done some cleaning on our data frame earlier. So what you can do here, yes, any dot. Okay, that's good. So what you can do, you can just directly data frame gives you how you are going to plot a histogram plot. Okay, so for histogram, you are going to the continuous data. Basically, when your data type of the column here is float, okay, float 64. So you can go for the histogram. Okay, so if you have your data type as a float, okay, so that means it indicates that that particular column or that particular feature will contain continuous data. Okay, so you can create histogram, and in the yes, in your this Pandas data frame. Okay, Pandas data frame provides to create here. So if you are taking one feature, okay, so don't confuse one feature if you are taking. So this will be up to here. If you go only this, only or this you go. Okay, so this will give you all the data, but data type, your data will be basically this whole thing. If you go and check that what is the type of this, so it will be basically series. So in the data frame, Pandas data frame, there are two different things. One is your data frame and other is series. Okay, so if you have only one column, so that will be series. Okay, and if you have multiple columns and multiple rows, okay, so that will be your data frame. So if you go only for, if you go and check for the only data frame, okay, so this will be your data frame that we have stored all CSV data into this data frame. Okay. So okay, let's check this one. So for the ozone, okay, ozone, these are the data. Okay, so what you can do, you can go and check the histogram. Okay, and in the histogram you can find that in between 0 to 25, how many 0 to 25 or something like 23 or 24, how many data points are there? You can find it, the 28 or 29. And in between this range, how many data points are there? Okay, so this will give you, okay, so these values appears very less. Okay, like 150 or 158 or 160, something around 170. These data you can find here, these data are appearing very less. The count is, this shows the count. Okay, this shows the count and this shows the actual data. Okay, so these data you can find it, these data counts are very less, either one time or two times. So somehow you can find they may be, I'm not saying, I'm not sure 100%, but they may be, you can't say that this is the outlier, but they may be the outlier. Okay, so other thing what you can do, the best way that you can plot box plot. Okay, so whatever the data frame your is, So data frame dot box plot you can use, and you can pass the column name. Okay, column is equal to column name. This is fine, and column is equal to whatever your column is. One column if you are providing, so one this box plot will be plotted, and if you are providing comma here, and it will give you different box plots. Okay, so what we are going to check, let's okay, this will give you exact. So this shows about the ozone column and box plot. Okay, so let me just describe that what box plot will do. So basically this is your the maximum acceptable limit. Okay, max limit, and this is your the minimum acceptable value in our data set. Okay, so if any data is greater than this, I think maybe whatever is it will be 125 or 124, something like that. Okay, so this will be the, let's say 124 or 125. This is your maximum acceptable value. Okay, and that is greater than that, this data point, let's say 128 or 130 or 135 something, and this is something greater. So these data will be treated as outliers. These are outliers. Okay, so you can remove these outliers, or you can but different techniques are there to deal with. You can remove basically either these two values, which rows contains these two values, just you remove if you don't need. Okay, that's one way that you can go. Other way that you are going to replace these values with the maximum value. Okay, this is your maximum value. Either other thing what you can do, you can replace these values with your median. This is your median. Okay, so there are different ways, there are different techniques that you can apply. Okay, so I think we haven't run this one, so just run and you will find. Okay, so you can check with different, like ozone is there, or the wind. Okay, I have written here for the winds also, so you can check for the winds also. Wind also contains some outliers. Okay, so you can check this way and you can deal the outliers. Okay, other way to that we have discussed, the other way to you go for the checking outlier, you can use describe function, and this function will give you some insight. 70% of the data are just below 61 value. Okay, 70% of the data are below your 61, but the maximum value is 168. So you can guess that this 168, the data that appears 168, will be what, will be your outlier. Okay, now just take this one. Okay, data clean, that this we have taken. Okay, now what other thing is that you can go for the bar plot also, for the, if you have your data is a categorical data. Here weather is what, weather contains only C or P, CS or as partly cloudy, PS. Okay, partly sunny or partly cloudy. So these three categories we have, S, C, and P, and what different values in these categories are, you can plot bar plot. Okay, just check these things. Okay, other thing we are going to deal, how you are going to deal with the missing values. So let me go with these. Okay, missing values. So max data increase, what does it mean? A max data increase, what does max data increase means? Okay, so max data, I think you are talking about max data, this one, 168. Okay, so max data, yes. So max data is in our here. This data is what? This is 168. Max data in, when you are going to deal with the dot describe, that will be what, that give you the maximum data, maximum value that is available in our data set. This is 168, this is available in our data set, but I written here max limit. Okay, maximum value that is treated as, maximum value that is treated as your maximum value that is treated as what, maximum value that is treated as your normal data. Okay, and these values, this is the maximum value available in our data set. Okay, and these will be the limit that will be our good data that we are going to treat them as normal data. And yeah, that's good. We can use fill NA, or we can find the missing data. Okay, yeah, that's good. You can use fill NA and different things. Either you can go for the just to calculate the mean or median or something like that, and you can just fill with those. Okay, the fill NA method is there using those. Okay, so we were dealing with missing values. Okay, and we are going to fill. Okay, so what you can do here, this is just to represent, just as soon as heat map you can create, just it will show you that how many missing values we have. Okay, so here this feature, ozone feature, has many missing values. This will give you, and solar will give you some missing values, and weather has some missing values. Okay, so just to find out how many, just visually represent how many missing values are, so you can find. Okay, so you can check that how many null values are there. Okay, so this is the data frame, and we already have seen the data frame dot is null, and it is going to take for whole data for any axis and for any feature. Okay, so for any feature it will check, and if you are not going with this, okay, let's say not head, only this one, so it will show you all the this rows, all the rows that contains at least one not a number. Okay, yes, someone says that what is nan. This nan is basically treated as a numeric value, but it will be not a number. Okay, it will come into the numeric feature. Okay, it will be treated as numeric value, but this shows that this value is missing, this value is not a number. Okay, actually this is saying not a number, but it will come into the float value. Okay, it will come under numeric feature. So all these are the missing values, not a number, not a number, not a number. Okay, so we are going to check these things. Okay, so any value that is null, any row that contains at least one not a number, a null value. Okay, it will show all these features. So all these rows contains at least one not a number. Okay, so every, see, 51th feature here is 51th rows. Okay, it contains one not a number, it contains one not a number. Okay, null values. So all these things, and you can already, we have seen this one, you can check. Ozone contains 38 null values, solar contains 7, and weather contains 3. Okay, how can you impute means just how can, what make difference if we add head? No, we are not going to add head, just we are checking. Head means here whatever the data you find here. Okay, you find 4 5, these many values are there, many for the NN, for NAN, makes that add head for them. Yes, that is the scene that you find that these rows contains at least any row, it will show any row that contains at least one NaN. Okay, and if you want to find the first five, okay, just you can check for the first five, where it is first 5 rows that contains NaN. So that is the same. Okay, and you can this ozone contains how many? 38. Ozone contains 38, not a number. So you can do what? You can find the mean of all not null values. Okay, so it will give you the mean of not all the not null values. Okay, so it is like 41. You can fill with this mean, you can find the median, you can find different way to is for first 5. Yes, the head is used to display, just to display. We are not going to store anywhere, just to display first 5 rows. Okay, that will give you the head. And in this case, this gives first 5 rows that contains null value. Okay, so all these contains this actually this was 5th row, but the first row that contains null, it was 6th row, it was 10th, and 11th and 25th. Okay, actually in our data, this data appears at 25th. Okay, that is the case. Yeah. So you can use fill NA and you can pass this value. Okay, you can fill NA and you can pass this mean value, and you will check that in the ozone now all the values. Okay, one thing what you can do, mean value to round. Okay, it takes like 41.0000, so it takes like many zeros, so we are not going to, you are going to just round to okay, only 10. Okay, so just you can round and now you can fill. Okay, now you can check. So okay, what happened? Okay, that is, let's say that we are going to take into on this, that is mean is equal to where it is, we have copied or not somewhere. Okay, that column is there. Okay, okay, no issue, no issue. What we are going to do, it is already where, so it is float and it's taking. Okay, we are not going to detail too much here. Any doubt? Attendance, please. Attendance is there, attendance available, and it will be shared, already shared, and it will be shared again. Okay, so what is the time? Do we have more time? Yes, we have like 25 or 30 minutes, so we can complete. And yeah, so you can go with these, and now you can check for the weather. What does this weather says? And yeah, weather has basically three. So you see here, so in this ozone is basically what, numeric value, and it is basically continuous data, so you can use mean or the median. Okay, but here the column that is weather contains categorical values. Okay, so categorical values, for categorical value you are not going to use mean, median and something like that. Okay, so for categorical you can use mode. Okay, the most frequent value you can use. Okay, so here we have what we have used, that mode. Okay, and in that mode the first one that appears most, so you can check, basically you can check that what does this give you. Okay, so just run this, and okay, so let me create another cell, so that will give you. Okay, what happened, okay. Okay, zero. First appears as zero. Okay, so mode gives the most frequent, So that is S. S is the most frequent data that appears in our data frame. That is whether column contains S or C or partly sunny. Okay, so PS3. So now you can use this S. Okay, now you can use this S to replace the null value in our weather column. Okay, so it will now give you, now there are no missing values. Earlier there were three missing values, now those missing values are replaced with this S. Okay, now you can check that what are the, okay, so one column we have deleted, so now only 9 columns are there, and this and object column you can find. Okay, so this was the weather column basically. Okay, and now what we are going to do, we are going to do, okay, what is this, concatenate. Okay, we are not going to deal all these things. Please give number and increase number and decrease number. What does mean increase number and decrease number? Are the like size of this one, or increase number or decrease number? What does it mean? Increase number or decrease number? Attendance is okay. Until you are going with this, what does it mean? Increase number or decrease number? Someone says increase number or decrease number. What does it mean? Nipu Yadav, can you clarify what does it mean increase number or decrease number, so that uh, I can take your query. Okay, sorry. Okay, So attendance is already shared. If you are if you joined late, so I think attendance will be shared. Okay, in just 1-2 minutes or some minutes. No issue. Don't confuse. Ascending and descending order. I think. Okay, ascending and descending order. No, no. What does mean of ascending and descending? Yeah, attendance is shared. Okay, ascending and descending order. Okay, just go and check that these are the important things that we need to cover. Okay, so if you want to find out, the relationship between two features, so you can just go for the scatter plot. Okay, scatter plot, and we are going to you are going to check that correlation. Okay, so this method, this SNS Seaborn already we have imported. So if you haven't imported, you can go for the import Seaborn and .ns SNS. Okay, and it will give you that pair plot and directly whatever the data you have cleaned. Okay, clean data or the data you have, so just give, and it will take all the numeric values, and it will all the numeric features and other features, and it will give you the plot. Okay, scatter plot and the pair plot with respect to different features. Okay, so you have your ozone and temperature. So if you can check, you can see here temperature and ozone. See for these two, temperature and ozone, how they are correlated, what is the scatter. Like here you see, you can see somehow if temperature is increasing, so little bit ozone is also increasing. Okay, and you can find also that these values, some values you are getting that are very far away from the rest of the data, so you can treat them as outliers. Okay, so these are the things that you can find. And wind and temperature, you can find the wind and temperature. So if temperature is increasing, you can see here the wind is little bit decreasing. Okay, so you can find here for the temperature and ozone, this is positively correlated. Okay, little bit positively correlated, not very strong correlation is there. And here you can find temperature and the wind little bit negatively correlated. Okay, so if temperature is increasing, the wind speed is decreasing. Okay, negatively correlated here. That only one value we have, so noise, that only one value we have, so it's a constant type. So you can find different pairs. Okay, so you can check these things, this is very important. You can check for the pair plot. Okay, so it will give you it will take two features and it will plot scatter plot, or if it is categorical, so it will plot your box, that is bar plot. Okay, so these are the categorical. Solar versus that, what is that? Okay, solar versus solar, so it is histogram. It will show you the counts, like counts. Okay, how many counts are there for that? Ozone versus ozone, so it is histogram. Unnamed versus unnamed, histogram. Other, these values you will get that these are the scatter plots. Okay, so this is what that we want to find out. Basically the input features without the temperature, without the weather. Okay, input features without weather. So all the input features, ozone is there, ozone, solar, wind, month, day, and temperature. And in our previous data, there were weather. Okay, so without weather, the last one here, last one we are not taking here. So all the things up to the last, but last is not included when you are going to the this one. If you go something like that, anything, the indexing. Okay, so let's say 3 is there. Okay, and start from 0, so it will take 0, 1 and 2. Okay, and the third, the last one, whatever the written here, that index will be not taken. Okay, so minus one is the last index. Okay, in the last index that we have weather. Okay, so this weather, the last index whatever you have written, that will be not taken, and rest of the last, all the features these are taken. Okay, so all the features here taken, and the last here one feature that was weather, that was -1, this -2, -3, so up to this you have taken, but the last is excluded. Okay, so last is excluded in the indexing in Pandas NumPy if you are going forward. So it will be, yeah. So this is just to take only the input features. If you don't want to take the the labels, the last one, so you can take like this, and you can find the correlation. This correlation, okay, this correlation will give you what? You can find numeric value. One thing that you can write here, and it says that earlier what was the case. This is showing error could not convert string to float me. Okay, so one feature this was this was containing month was containing something like it was your May, it was containing May. Okay, so that why it was showing. So what you can take you can find out. I think in the data clean 4 we have used, if we have used this or not. Okay, could not convert it. This is also data clean 4, data clean 5. What was that? Okay, so let's take this one, and you can pass numeric value, this parameter, and if it is true, so what it will take? It will take only numeric features. Okay, that contains numeric values only. Okay. So what it will take: ozone, solar, wind, and temperature. These are the numeric feature that contains numeric values. Okay, it will give you all these correlations. Okay, so if correlation is exactly 1, so that means these two features, unnamed and unnamed. So same here we can say ozone and ozone. So these same feature is correlated to itself, that is 100%. If anything, like here, ozone is correlated positively 0.3 with solar. Okay, so the strength is 0.3 and ozone is correlated with the solar. So if ozone is increasing, so solar is also increasing, solar radiation and solar values. Here you can find out any other positive. Ozone with the wind, ozone with wind, is it negative, negatively correlated? Okay, so 0.5, so it is negatively ozone, the wind is increasing, so ozone value is decreasing, ozone value is decreasing, wind is increasing. So these type of the things you can find. So correlation is very important when you are going to deal with like regression and for the prediction purpose. Okay, these things. So one thing that I wanted to show you, that what you can do this, either you directly convert this month to numeric values. Okay, so wherever the May came, it will convert as a not a number. Other way, what you can do, you can replace this May with 5. You can replace this May with 5, and now you are going to find out this 5 as this thing, and now you can convert this column into the numeric value. So this will not create any not a number. Okay, that's a good thing. Now up to this we have done a lot of things, missing values we have done, and all these things we have done. You can use different methods, drop NA, or you can use fill NA, is null, not null. We have done all lot of things. Okay, scatter plot also we have shown, correlation also we have seen correlations, and these things, transformations. So one last important, and it's very important, and it will come under the feature engineering, that always we are going to do. Okay, so this is very important, that is feature engineering. So whatever the machine learning, when we are going to create our machine learning models, supervised and supervised models, so always any categorical data or any text data, if you have in your data set, so you have to convert into numeric data, because all the machine learning models are going to should be fed with your numeric values. Okay, so this SC and PS, the machine learning models are not going to deal these type of the data. Okay, so you have to convert into numeric values. So there are different types of the different ways to convert categorical data into numeric values. So one is the one hot encoding, and this what it will do, it will take how many unique values that this particular categorical feature has. Okay, so this weather contains 3 unique values like C, S, and PS. So what it will create? It contains 3 unique values in this weather. So it will create 3 features for each unique values. Okay. So it will create one weather for C, one weather for PS, and other for the S. Okay. So wherever, just to understand, it's very important. Here S is there. So this is for the S. Okay. Weather column is now converted into 3 columns, and it will take either S or C or PS. So wherever S came, it will give the one value, and rest it will give 0. Here C came at 36. Okay, you can see ozone is 36. So for this value, it is C. So for the C, it gives 1, and for the rest, it will give 0. Okay, so it's not only that 3 columns, it may be 5 or 6 unique values. So what it will do, it will change, it will convert this feature, one feature, into the different feature, depending on how many feature values, unique feature values are. So here 3 unique feature values are there. So it converted, and using get dummies. Okay, you can use get dummies. So it converted into 3. And again, I'm saying that if you are using, if for this particular column, for this particular feature, not feature, sorry, for this particular row or the data point, this whole data point belongs to category S. Okay, now it will belong to this category C, whether C, sorry, whether S here. So it will give S as 1, and for other whether C and whether PS as 0, 0. And for here you will see that 18, and it is belonging to 12 belonging to PS. Okay, so 12th one is belonging to PS. So for the PS, it will give 1, and rest it will give 0. So this is one way that you can convert. There are different ways, that you convert, you can use. Sorry. So what is that? Okay, feature scaling is there. So maybe if time permit, we can see these things. But let's first do our that one. Okay, so what can you do? You can do for the dummies. Okay, so creating dummy variable for the weather. What is that? Here, see. True false, don't confuse with true false. This is what it is. False is there, so it is 0, and true is just 1. Okay, so you can create dummy variable. Dummy variables are the dummy features. Okay, now the feature that was weather, now this weather feature or this weather variable is converted to the these 3 dummy. Okay, these 3, so whether C, whether PS, and whether S. Okay, so wherever we have seen that if it is if this first data belonging to that S category, so now this will be true, and rest of the 2 will be false. We can print this one, and for all these things you can see here, this data 153rd data was belonging to category C, so now it belonging to weather C category. Okay, so what is that? Drop in a, okay, again that is not a case. So what we can do, feature scaling. So we can go, we have just 5 to minutes, we can go with the feature scaling. Okay, so what basically feature scaling do, why feature scaling is important, and what different things that we are going to perform here. Let's say, okay, that we can complete. Sorry. So basically, when we are dealing, let me show you the data, actual data. Okay, so here you find the ozone. Okay, ozone was somewhere you can see 41, 36, 18. Okay, these things. Solar R is 190, 118, something like that. Okay, so here you can find, and here you can find like 7.2, 12, 10, and all these things. Okay, so in wind, you can find most of the data are something like that, 12, 11, 10, 20, around 20, 11, 9, and these things. But if you go in solar, you can find 100, 299, and 334, 30. Okay. So the scale is different. Okay. So if you are going to feed these data, if you are going directly feed these data to the machine learning model, so what there may be a problem that machine learning model treat the larger values a column or a feature that contains larger values may give a like more weightage. Okay, so what we are going to do, we are going to transform all data in a particular scale. Okay, so if you are going to convert using z-score, you can find all the values mean. You are going to subtract the mean and you are going to divide by the standard deviation. So this what it will do. It will convert your data like this. The mean will become like your mean of the data will become 0 and standard deviation will become 1. Okay, so all the data, all feature values will be transformed in a such way that mean will become 0 and standard deviation will become 1. And most of the time, if it is normally distributed, so your data points will be in between 3 and 3. Okay, so now some data points here, you can see some data points were like 100, 200, 300. Here some data are like 62, something like that, 7.5 something here data. So now all the data are transformed, all the data are most probably transformed into -3 and 3. If outliers are there, so little bit go out of this range, but all the data will be converted into this. Okay, so you can use this one. Either you can use min max. Okay, min max value. You are going to do what this formula you can use. You are going to subtract the minimum value from all values and you are going to divide by maximum minus minimum. Okay, so this will give you normalized value, and normalized value in will come in between 0 and 1. Okay, so all the data will be transformed into 0 and 1. Okay, so here all the data will be transformed in 0 and 1. All the values, let's say 399 we have. Now it is converted into either 1 or something like that, but the data will be converted in 0 and 1. And here data is converted most of the time -3 to 3. Okay, so you can use standardization and normalization. Okay, so that your data fall in same range. Okay, so here just for the min max scalar, something like that, whatever the things are, the different things that we can use. Okay, so first thing what we are going to do, we are going to import numpy and we are going to import sklearn. If you are working on your local machine, okay, you are not working in Colab, so you have to install all the libraries. Okay, numpy, pandas, scipy, and sklearn. Okay, all these things you have import whatever the install and import. Okay, so first thing, what different values we have? We have 141, 190. This will be for what? For the first row. This will be for the second row. This will for the third row. Now this is converted into array, numpy arrays. Okay, and you are going to, what you are going to convert, you are going to convert into min max. Means this one we are going to take min max. Okay, so we are going to normalize, so all the data will be converted in between 0 and 1. Okay, so here you can find so it will be 0 and this, that 41 is converted into 0.24 and something like that. You will find 0 0 all these things. Okay, so now your data, this thing we have. Okay, so you can check for all the data. Why only for this? Okay, you can check for the all the data. So you can find it. Okay, so all the data you can check. All the data are converted into between 0 and 1. It's transformed, normalized between 0 and this one. 0 and all the values you can check. No value is greater than 1 and no value is less than 0. Okay, so all the data is converted. Okay, this way. Other thing what you can use, so standard, you can standardize. Okay, so other thing is like z-score. Using z-score standardize, that we already seen that this whole data will be converted in between -3 and 3. There are some exceptions, that if data has some outliers, very extreme values. So in this z-score, what is the issue? That those extreme values will go beyond the maybe greater than 3 and maybe less than -3. Okay, so most of the data will fall in between -3 and 3. Okay, so all the values you can see here. If you go with standard scalar is not defined. Okay, so somewhere we have imported or not imported. Okay, this one we have to import. Okay, so you need to import the standard scalar. Now you will do, and you'll find you'll find now, check that I have taken only the first row, first 5 rows. Okay, so first 5 rows you can check any data is greater than 3 or any data is less than -3. No, you are not getting. So most of the data, if you go for the all rows. Okay, so go for all rows and all columns. Oh, sorry, 0 0, it will not take. So just do this one. Okay, so all the data you get. Okay, better to have those one, so it's not showing all the data like this, so you can have like this. Okay, first 5 rows, and you can check. So you can check that no data that is greater than 3 and no data greater is less than -3. Okay, so see here, this is for the first feature, this is for the second feature, this is for the third feature, this is your for the weather column, this is your for all these things. You can check what different features we have. Okay, so you can find okay, this is basically okay. Let's check that what different features they particular have. So you can check columns. Okay, sorry, columns. Okay, so different feature, it clean data for contains these. Okay, so like this unnamed will related to this one, ozone, this is related to solar, this is wind, and these things. Okay, and this one is weather C, weather PS, and weather. These last three are for weather P, weather PS, and weather C. It was like 0 1 0 1. Now it is converted into some values. Okay, so all the values here, you will see all the values are converted into the same scale. Okay, same scale, what means same scale means all the values are in range this and this. And here earlier, all the rules when we normalized, all the values are in between 1 and 1. Okay, so now if you are giving standardized or you are giving normalized data, okay, so now there will be no no effect of the value size of their scale of the values. Okay, scale of the feature. So all the feature values are in, whether it is ozone or whether it is wind or whether it is month. Okay, or whether see, all the values are in this range. Okay, so now there will be not a chance of that. If our one feature, let's say one feature, this contains big values. Okay, 300 400 something like that, and this width contains 30 10. Okay, something like that. So now if your data earlier, our data contains like these values, this ozone contains bigger values, let's say. Okay, and this width contains some smaller values. Okay, so what will be the problem at that time? Machine learning model may treat that these values are the bigger, so these values may give these values as a more like more weightage. Okay, and here the smaller values may get the less weightage. Now all the data for all features are in the same range, on the same scale, so there will be no chance of getting one feature more weightage and other feature less weightage. Okay, so before going to the machine learning model, you need all these things to work. Okay, so almost all the things we have covered. Okay, we have done a lot of things here. Okay, one hot encoding, and we have already seen one hot encoding, level encoding. There are different other ways of the level encoding. Okay, so almost we have done last almost all the things. So let me just summarize that what we have done. Okay, so we have cleaned, we have done missing values, data analysis, scatter plot, scatter diagram, correlation analysis, transformation, then min max transformation, and that is normalizing basically any standard deviation Z transformation that we have done for the standardized data. Okay, so all the things, one thing is remaining. Okay, if time permit, I will show either when we are going to do the things, so we will take in any other day. Okay, so all the things we have done related to the data that we are going to deal with the data. Okay, so from the next session, that will be on Monday, we are going to work on supervised machine learning, and we will talk about we will deal with regression analysis. Okay, and we will implement regression analysis, linear regression. Okay, and we will see that how linear regression works and how you are going to predict when you can find linear regression model. Using linear regression model, how we are going to predict some new values. Okay, so hope this session was good and you got some insights. And yeah, so we are going to conclude here. Over to you, ma'am.
Yeah, sure, sir. Is I'm audible, sir?
Yes, yes, yeah.
Yeah. Okay. So yeah, like tomorrow and day after tomorrow, we don't have a session. We are meeting again on Monday, sir.
Yes, 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 sure.
Okay. Yeah. So dear students, as you all know, Saturday and Sunday we don't have a session. We'll meet again on Monday at 7 p.m. Okay, attendance link has been shared once again on the chat. Kindly mark your attendance. Okay, so can we wind up for the day?
Yes, 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 ma'am.
Yeah, thank you, sir. Thank you so much. We'll
You're
meet
most
again
welcome.
on Monday. Yeah.
Yes, ma'am. You're
Thank you,
most
dear
welcome.
students. Yeah, good night.
Good night, all.